Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of adding and subtracting rational expressions with unlike denominators. First, let's review my suggested steps for adding and subtracting rational expressions. First, initially, keep the numerators unfactored. Second, factor each denominator and determine the LCD. Remember, the LCD is going to be a combination of all unique factors that are in the denominator. Multiply any missing factors from each denominator as an equivalent of 1, so it would be fraction over fraction, or value over value. Distribute in the numerator, but keep denominators in factored form. Add or subtract the numerators. Keep in mind that if it is subtraction, the entire numerator is being subtracted, and therefore you need to change all the signs. Combine the like terms in the numerator. See if if the numerator could be factored, and then, if possible, simplify. In our first example, we want to combine these two darling rational expressions. So what do we have? We have 6y plus 5 over, I'm going to factor this, so let's see, we have a GCF of 5. That would give me 5 times y minus 5 minus y plus 2 over y minus 5. And this is just saying, it's just saying y can't be 5. It has nothing to do with the subtraction. It can't be 5 because then we would have zeros in the denominator and that'd be a huge problem. That's the only reason that's written there. Okay, so what is our LCD? The LCD, we need any unique factor. So I see here we have a factor of 5 and we have a factor of y minus 5. Now we already have a factor of y minus 5, so we don't need to include another one. There's our LCD. This term already has the LCD. Yay! This one's missing the factor of 5, so I'm going to multiply by 5 over 5. Keep in mind that everything gets multiplied by 5 in the numerator and the denominator. Okay, so now we can combine our numerators. We're going to say 6y plus 5 minus 5 times y plus 2, all divided by that least common denominator of 5 times y minus 5. We want to be really careful. So I took this extra step because we do have that subtraction. You need to make sure that you distribute the subtraction to both terms when you factor the 5. If you don't distribute it, you're going to end up with the wrong answer because you're going to be doing the wrong sign. So just be really, really careful when you see the subtraction sign. Okay, now I get to distribute a negative 5. I get 6y plus 5 minus 5y minus 10 all over 5 times y minus 5. So notice I'm keeping the denominator factored, but I always distribute in the numerator. Now in the numerator, we're going to combine like terms. I have 6y minus 5y is 1y. 5 minus 10 is negative 5. And I can't factor the numerator, but it is itself a factor. And I see that we do have a common factor. I see a y minus 5 factor in the numerator. I see one in the denominator. And I actually end up with 1 over 5. Very five-tacular problem here. We end up with 1/5. Okay, in our next example, we have 2x minus 8 over 3x squared plus 8x plus 4 plus 3x plus 3 over 3x squared plus 5x plus 2. And I know it's super tempting. I see that 2x minus 8 can be factored. Resist the urge. We do want to factor the denominator. So starting with that left denominator, so we're going to call it the left denominator, where we have 3x squared plus 8x plus 4. We need to factor this, and we might want to use target product, target sum. Target product here is going to be 3 times 4, which is 12. And the target sum is that middle coefficient of 8. Two numbers that multiply to 12 and add up to 8 would be 6 and 2. So we're going to replace the middle term, that 8x, with 6x plus 2x. This would be 3x squared plus 6x plus 2x plus 4. This allows us to factor by grouping, so I can group my first two terms, group the second two terms. The greatest common factor of this first grouping, 3x squared plus 6x, is 3x, leaving behind an x plus 2. In the second grouping, the GCF of 2x and 4 would be 2, leaving behind an x plus 2. Between these two terms, term 1 and term 2, we now have a GCF of x plus 2. So we're going to factor out the GCF, write what's left over, 3x plus 2. Okay, so that was the left denominator. How about the right denominator? We want to do the same thing. We have 3x squared plus 5x plus 2. The target product will be a times c. That would be 3 times 2, which is 6. The target sum is that middle coefficient, which is 5. Two numbers that multiply to 6 and add up to 5 would be 3 and 2. What do we do with 3 and 2? We replace this 5x with 3x plus 2x. Then that gives us 3x squared plus 3x plus 2x plus 2. Having 4 terms allows us to factor by grouping, so I can group the first 2 terms, group the second 2 terms, find the GCF of each grouping. Here would be 3x, leaving behind an x plus 1. This one would be a 2, leaving behind an x plus 1. These 2 terms have a GCF of x plus 1, so we're going to pull out that x plus 1, and the leftovers are 3x plus 2. Okay, so now we can replace each denominator with their factored forms. So we would have 2x minus 8 divided by x plus 2 times 3x plus 2 plus x plus 3 over x plus 1 times 3x plus 2. Now let's see what our least common denominator is. So our least common denominator, let's see, we know we're going to need each factor from the first term, so I need a factor of x plus 2 and 3x plus 2. And the second denominator already has a factor of 3x plus 2, so what does it add to the situation? It has an x plus 1. Now I know this first rational expression does not have the x plus 1, so we're going to multiply the numerator by x plus 1 and the denominator by x plus 1. The second fraction is missing x plus 2, so we're going to multiply the numerator by x plus 2 and the denominator by x plus 2. Remember what we do next. We keep the denominator, and since I'm running out of room, I'm just going to combine them and distribute as I go. So we're going to keep that common denominator, and now we can put the 2 numerators in one fraction, and we're going to distribute the numerators. So I'm going to do x plus 1 times 2x minus 8, and that would give me 2x squared minus 8x plus 2x minus 8, and I'm going to distribute that second numerator as well, so that would be x times x is x squared plus 2x plus 3x plus 6. And now we're going to look for like terms in the numerator, so I have 2x squared and x squared would be 3x squared minus 8x plus 2x plus 2x plus 3x. Well, that's going to be minus 6 minus 3 minus 1, so we're left with minus x, and then we have minus 8 and positive 6, which will give us minus 2. Now the question is, can we factor the numerator? So is 3x squared minus x minus 2 factorable? Well, if it is, the target product is negative 6. The target sum is negative 1. I think it's factorable, so I'm going to go down here. 3x squared minus x minus 2. Let's see, target product, remember what I just said, was negative 6. Target sum is negative 1. What are 2 numbers that multiply to negative 6 and add up to negative 1? That would be negative 3 and positive 2. So we're one more time going to replace that middle. We're going to write it as 3x squared minus 3x plus 2x minus 2. And now we can factor by grouping. This would be 3x times x minus 1 plus 2 times x minus 1. And that would be, our numerator is going to become x minus 1 times 3x plus 2. All right, so we have x minus 1 times 3x plus 2. Does that simplify with anything in the denominator? Yes, it does. We have a match. We have factors of 3x plus 2. And so our final answer, which I of course have no space for, is going to be x minus 1 over x plus 1 times x plus 2. And I would leave it like this, except I want to make this a little bit neater. I would leave it like this, but you should talk to your instructor about if you need to multiply through in the denominator. Hopefully not, because I always say less is more. Okay, how about this example? Hopefully this one's a little bit less labor intensive. It looks like it is. Okay, so it looks like nothing can be factored. We have 8b squared over 4b minus 5 minus 2b over 3, and then we'll just turn this into 1 over 1 just because we need that fraction. Yeah, nothing can be factored here, so we have one factor of 4b minus 5 and one factor of 3. This first rational expression needs the factor of 3, so we're going to multiply by 3 over 3. The middle needs that 4b minus 5 over 4b minus 5. And the last one needs everything, right? Because it only has a denominator of 1, so we need to multiply by 4b minus 5 times 3, 4b minus 5 times 3. Okay, so we end up with our one giant denominator. And it's actually not that big. It's 3 times 4b minus 5. And then in the numerators, we have 3 times 8b squared is 24b squared. In the middle, we have minus. Remember, this minus belongs to both terms, or any of the terms that come after the subtraction. We're going to have 8b squared plus 10b. And then minus, so I'm going to think about this as minus 3 times 4b minus 5. So that would give me minus 12b plus 15. Right, so I'm just thinking about this as it comes after that subtraction, so it's minus 3 times 4b minus 5. So I'm just attaching the negative to the 3. Okay, we're going to look for some like terms. Look, they're all right next to each other. So we have like terms right here. Okay, why did it stop writing? Hello? We have like terms right here. 24b squared minus 8b squared will be 16b squared. Right here we have 10b minus 12b is minus 2b. And then plus 15. Oh boy. 3 and 4b minus 5. Now, it doesn't really matter if this numerator could be factored. It does matter if 4b minus 5 happens to be one of the factors of it. So we're going to play the guessing game to see if 4b minus 5 is a factor of 16b squared minus 2b plus 15. So the question is, does this equal 4b minus 5 times, and we're going to fill in what the first would be. So 4b times what would give me 16b squared? That would be 4b. And negative 5 times what would give me positive 15? That would be negative 3. Okay, so we have something, but we need to make sure we know that they multiply to the 16b squared and the 15. What we don't know is if when we multiply outer and inner, if those two terms will add up to minus 2b. So that's where we're going to check. This is negative 12b. This is negative 20b. If I combine these, does that add up to minus 2b? It doesn't. So whether this numerator can be factored or not, we don't really care, because we would only care if it had a common factor with the denominator, and we know that it doesn't. So this would be our final answer. We're going to leave it at that.